Hey everyone! Today we're diving into two really smart ways to solve some of the most complex problems out there. And what's cool is they're inspired by things you'd never expect, like climbing a mountain or even forging a sword. Let's get into it. So let's start with a big question. Imagine you have a problem with trillions upon trillions of possible solutions. How in the world do you find the single best one? You could try to brute force it, check every single option, but that would take, forever. It's just not possible. We need a smarter way. And this whole search for the best answer, well, there's a name for it: optimization. It's all about finding the most effective solution out of all the possible choices. And you see this everywhere, from figuring out the most efficient route for a fleet of delivery trucks to training an AI. It requires some pretty clever strategies. To really get a feel for this, let's use a great analogy. Picture this. You're lost in a dense forest, and you've got 0 bars on your phone. You know that if you can just get to higher ground, you might get a signal, but you can't see which hill is the tallest through all the trees. What do? What's your strategy? Well, the most obvious, most intuitive thing you do is actually an algorithm called hill climbing. And yeah, it works exactly how it sounds. The logic is incredibly simple. You start right where you're standing, you look at the ground immediately around you, figure out which direction goes up, and you take a step. Then you do it again and again, and you just keep repeating that process until you're at a spot where every single direction around you is downhill. Simple, right? You've reached a peak. And that's pretty much the formal definition. Each step you take is just a small change to your solution, and uphill just means it's a better outcome. The algorithm just keeps making these tiny improvements until it literally can't find another one. But, and this is a huge but, this simple strategy has a massive built-in flaw. It's a trap, and it's almost impossible to avoid. So let's meet Venla. Think of her as a mountaineer who's really nearsighted. She can only see what's immediately in front of her. So she uses that hill climbing strategy perfectly. She only takes steps that go up. Once she gets to a point where she can't step up anymore, she stops, plants her flag, and thinks, "I've made it. I'm at the top." But did she? Did she actually make it to the highest peak? Almost certainly not. Venla is probably standing on a small little foothill, totally clueless that the real, much taller mountain peak is just over the next ridge. She's stuck. And this story just perfectly explains the difference between a local optimum and a global optimum. Venla found a local optimum. That's her small hill. It feels like the top because from where she's standing, everything else is lower. But the global optimum, the actual highest peak in the entire mountain range, might be somewhere else entirely. Hill climbing has no way of knowing it missed the big one. This is exactly why hill climbing is known as a greedy algorithm. It's greedy because it only takes the immediate win, that next uphill step. It would never, ever take a step down, even if that little dip was the only path to a much higher mountain. It just can't see the bigger picture. So how do we escape this trap? How do we build an algorithm that's smart enough to sometimes take one step back in order to find a much bigger leap forward? Well, fascinatingly, the answer comes from the world of metallurgy. And this brings us to simulated annealing. See, when a blacksmith forges metal, they heat it up until it's glowing hot, and then cool it down very slowly. That process is called annealing, and that slow cooling lets the metal's atoms settle into a really strong, low-energy state. This algorithm basically mimics that exact idea. And here is the secret sauce. This is the whole game. While hill climbing is greedy and only goes up, simulated annealing introduces a wild idea. Sometimes it's actually a good thing to take a step downhill. It's a calculated risk. So how does it decide when to take that risk? Well, it all comes down to a bit of probability and a really clever concept that it borrows from metallurgy called temperature. Now, this temperature isn't real heat. It's just a variable we control that represents how much randomness or chaos we're going to allow in our search. Think about that hot metal again. The atoms are vibrating like crazy, moving all over the place. In our algorithm, a high temperature just means more randomness and a much higher willingness to make bad moves just to explore new territory. So at a high temperature, right at the start of the search, the algorithm is super adventurous. It's got a really high chance of accepting a downhill move. And what that does is it lets it jump off of those small hills, escape those local traps, and really explore the entire landscape, looking for new, taller mountains. But as the process goes on, the temperature gradually cools down, and at a low temperature, the algorithm gets way more cautious. It is far, far less likely to accept a downhill move. It starts to behave a lot more like our original hill climbing algorithm, zeroing in on the top of the best peak it's found so far. So the whole process is really a journey from chaos to order. You start hot and random, bouncing all over the map to make sure no major peaks are missed. Then, you slowly cool things down, reducing that randomness until it settles gracefully onto what is hopefully the global optimum, the highest peak of them all. So, to sum it all up, hill climbing is your fast, simple, but nearsighted strategy that gets trapped really easily. Simulated annealing is the smarter, more patient explorer. It embraces a little bit of chaos at the start to avoid getting stuck, using that temperature dial to shift from wide-open exploration to a laser-focused search for the best. And that kind of leaves us with a final thought. This isn't just about algorithms, is it? We all have a tendency to hill climb, to only make choices that seem like an immediate improvement. So what are the local optima in our own lives, or our careers? Could injecting a little simulated annealing, taking a calculated risk, a random coffee meeting, learning a totally new skill, be the very thing that helps us leap off a small hill and find a much, much higher mountain?